geometric settings. The last part of 6.3, coming off of binomial distributions. And if you remember binomial distributions, I think my wife's water just broke. She's only 4 months along, but she just cracked a soda and it just started. Anyways, it's just water, I guess. Yeah, so it was right. Anyways, where was I? Oh yes, binomial distributions. They have the bins, all right. Remember, where it says, what's the probability of 2 out of 7 things that are, 10% happen 10% of the time? What's the probability of that happening? Well, now we're getting into geometric, all right. So, basically, in short, geometric isn't just like 2 out of 5 or 7 out of 10 things happening. Geometric means I'm gonna go until I reach success. So I'll fail, and then finally success. So I could tell you this story. When I was in middle school, my brother and I, we would always go down at lunchtime. We'd always go to the park and play basketball. My brother's a good 3 years older, so I was in middle school. My brother was in high school. And I really didn't have a shot. Not really a shot in the world to beat him. And besides that, he's like already like 4 inches taller than me now. And this was before I hit my growth spurt. And so we'd always play. Okay, alright, anyways. Okay, so here's the deal. Every single day, we'd go down and we'd play. Rain or shine, we'd go down and play. I'd get my rear kicked every time. Just bam, 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 bam. There was one day, one glorious day, I beat him. I shot one of those haymaker 3-pointers and just drained it. Man, was he upset. Man, was he upset. He had to play another time. But I beat him the one time, so I played him and failed, but I finally got success. That is a geometric setting. Alright, so notice how geometric setting is going to be slightly changed here. Binary, is there 2 outcomes, success and failure? Okay? Alright, so it's got to be binary. It's got to be independent, otherwise I just can't multiply them together. So independent means that one does not affect the other, right? One time does not affect the other. Here's the kicker that changes. On a binomial distribution, we had these things called bins. Notice now it's bits, like bacon bits. That's right. I love bacon bits. So the T is the only thing that changes for geometric, and the N stood for a set number, meaning like 10 times. With geometric, the trials will go, we will go and go and go. We could maybe play basketball, 50 million times. Now, it didn't take me 50 million times. But I'm going to go until I get one success. Alright? Or one failure, whatever way you want to look at it. I'll go until I fail, right? It's the first time, though, you reach it. So it's not, I'm going to go and go and go and go until I get 2 successes. That's not geometric. Geometric is if I go and go and go and get my first success. That's geometric. Okay? Alright? Then also, finally, the last thing, successes on each trial probability must stay the same. So if I had this shot the first time, I've got to have the same shot the second time. Alright, so let's go through a couple situations here. Alright, blah, 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 blah. If you need to fill out the notes, you can pause it. I'm not going to spend any time doing this. Okay. Let's go. Let's do some story problem. Mr. Sheevy's going to play a game. Alright? How much homework his students will have to do for 6.3. If a student can guess the day of the week one of his friends are born on, then he will not add on any more homework. So, I'm going to think, speaking of my brother Jonathan, what day of the week was he born on? Alright, so I'm going to have somebody saying, you can say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. You get 7 choices, right? Now, if you guess it right, no more homework. No homework. But if you guess it wrong, everybody's got to do one problem. All right? Does that make sense? So then maybe the second time. All right? So you didn't get Jonathan's birthday right? Okay. Now, if I kept Jonathan, it wouldn't be geometric anymore because now we know one day is not it. And so the probability now of guessing correct would be 1 out of 6, right? So that would be violating the independent and the successes have to stay the same. So that violates both. So I have to pick a different friend. So if you don't guess Jonathan, too bad. Now, here's my second friend, all right? Katia. Okay, Katia, I was friends with her in high school. What day was she born on, all right? And if you don't guess it right, okay, another problem to do in homework, okay? And then we'll, say Chad. Chad was my dog, right? You guys remember my dog? Remember the horror stories I used to tell? What day of the week was he born on? I'll give you a hint. It was July 18th. All right. If you can't guess his birthday, boom, another problem. Okay, so verify that this is a geometric random variable. So first of all, is it binary? Do we have a yes and a no, or a success and a fail? And I would say yes, we do have a success and a fail. Do we have independent? All right. Well, as long as I'm coming up with different friends every time you guess, it is going to be independent, right? If I stuck with the same friend, then you guys would be able to guess, all right? So, yeah. All right, well, I might as well just scroll this thing down. Yes, success, correct guess, failure, incorrect guess. I, result of one student's guess had no effect on the result of any other guess, okay? T, is there a, will we go until we reach a success finally? So I will just keep going. I'll list off. I had like 1 million friends, guys. I was quite popular. I was the, okay, so I was homeschooled. But, I knew people's names. Some of them. Okay. Anyways, so we can figure out. We're just going to keep going. Okay? So we'll go until somebody guesses correct. And then finally, S. On each trial, probability will still be 1 and 7, right? So the success will always be 1 and 7, and that's because I keep changing new friends every single time we guess. Okay? So, here we go. It says, calculate. Alright. We don't want to do that. Calculate. What's the probability of getting it right the first time? What's the probability of guessing it right the first time? That means no failures. It means basically I have to guess it right the first time. And hopefully you guys would have to say, hey, probability of guessing it right the first time is 1 in 7. Alright? You guys good with that? Okay. What's the probability of guessing it right the second time? Okay? So that means, I want you to understand, I have to fail. I have to fail first, which a failure would be 6 out of 7. Alright? I have 6 out of 7 ways to fail. So I have to fail, that's 1 failure, and then I need to get it right on the second time. So I need to have it a success the second time. Okay? So I would literally just multiply those two. Now, is there multiple ways this could happen? Could I have the 1 7 go first and the 6 7s go second? And with geometric, here's the beauty, is I don't have to put combination. You're going to put a crosser. There's no other combinations. I have to fail first and then succeed. So literally, I'm just going to multiply these together. You should hopefully say that's 6 over 49. Which 6 out of 49 is 12, right? You guys getting the drift of geometric? It's super fun. Geometric's easy. You don't have to worry about combinations. Alright, probability of getting 3, okay? Of getting it right on the third one. So, well, let's see. That means I would have to get it wrong the first time, which is a 6 out of 7. I have to get it wrong the second time, which is a 6 out of 7. By the way, I hope you guys realize this is the last probability lesson I'm going to teach you guys. And then it's all inferences after this. So 2 wrong, and then finally I get 1 right. Or you guys get 1 right. Right? Okay, so there you go. That is a probability of getting 3, right? On the 3rd try. So 1, 2, on the 3rd try guessing it right. Do I have combinations? No. I must get fail, fail, succeed. There's no, I can't succeed, then 2 fails. I have to fail, fail, succeed. Alright, so the probability of that is going to be that one. Notice each one kind of goes down, right? Each one goes down. And the probability as we approach K, hopefully you'll realize, as we approach K, that's all the ways it could happen. And what's the probability of all the ways it could happen? I'm sorry, as we approach K, or an infinite amount, hopefully you'd say it'd be like 0%, because it keeps going down, 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 down. In fact, your greatest, with geometric, the greatest probability is getting it right the first time. It just keeps getting worse after that, guys. Alright? Okay, let's see another situation. Okay, Shaquille O'Neal. What a beautiful free throw percentage. Who knows Shaquille O'Neal? Is he too old now? Am I dating myself? Okay. Anyways, what's the probability Shaq misses 5 free throws before he makes his 6th? So, this is geometric, right? Because he's going to miss, 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 and then finally make his 6th. So here's how I do it. I'm going to go 0.527. That's the probability he makes it, right? Okay? So that, I want that to happen the 6th time. So there's going to be 5 previous of the opposite. And the opposite of that would be 0.473. And how many of those do I want? I want 5 misses. I'm going to do shorthand. So 5 of these suckers, and then a success, right? So 5 failures, 1 success, multiply them together. Let's see this. 0.473 times 0.527. Alright, the answer is, what's that probability? 24%, 24, 9, around to 3. Alright. You have 24, almost 25% chance he misses 5 before he makes one. And believe you me, he's done that many times. Missed 5 in a row. Oh no. I thought this was a little high. Forgot to put the 5th power. Oh my goodness. 0.473 to the 5th times 0.527. Alright. So he's got a 1% chance. 0.0125. Alright. There, that's a little bit better. Okay, that's the shot he's got. What's probably Shaq makes a free throw in 4 or less? So he makes it on the 4th shot, or the 3rd shot, or the 2nd shot, or the 1st, or 0, right? So you could do 4 of these, right? So it would be 0.473. Means he's got to miss this. He's got to miss 3 times and make it on the 4th, which would be 0.527. That would be the probability of 4, right? Getting it on the 4th. Probability of a 3rd would be 0.473. So he's going to miss 2 of them. Sorry, we're going to do this. I know it looks a little ugly, but... Alright, so I want 2 misses, and then on the 3rd time, getting it, get her done. Right, and that's going to be 3, and so on and so forth. Now, we do have a thing in our calculator, and I'm going to just kind of show you this, because we're almost done with our lesson, but if you go to second vars, and you go down enough, you get your binom, CDF, binom, PDF, and if you go down far enough, you see geom, PDF and CDF. You can feel free to use those And it's the same deal. CDF, everything below it. PDF is exact value. Have a great day, guys.